1 is crossing. Okay. Negative 3, 0, multiplication is 2, so it's going to be touching. Well, in here called touching, but we should say that the graph is tangent to the x-axis. This is a more formal word. Tangent. Okay. I see that I read the book before I record the video and say the book says touching, so I got touching. And then what? 1 right here multiplies 3, still R, so it's still crossing right here. Okay? And I graph my calculator. I see is I'll just show you a rough graph of it. It's going to look like this. Okay? This point right here is at negative 3. This point right here is at, what's that? 1. This one right here is at 2. Okay? See? Degree 6, right? So both strengths are going to be either both up or both down. The leading coefficient negative 3, a negative number, so you see the graph this way. Remember the very first property we learned? Even degree, negative leading coefficient, the graph tends to be like this. Okay? And then we have 3 zeros with multiplicity. X equal negative 3, x equal to 1, and x equal to 2. Negative 3, 1, and 2, right? 1 and 2 with odd multiplicity. The graph is crossing the x-axis. X equal negative 3 is even multiplicity. The graph just touching the x-axis. And I claim for now, you guys just roughly learn about the graph. You want to know more about those points going up and going down. You're welcome to take Calculus 1. Right? This is college algebra and pre-calculus, and then Cal 1. And we're going to learn more. We learn something called derivative. It helps you guys to learn about the graph a bit more. Okay. Now let me talk about the last item for this section, and then we're gonna call it the end. It's something called the turning points. I just use this graph to explain to you turning points. Probably number 3. Turning points. Recall what we learned before previously. We have something called the local maximum or local minimum. Now in the graph, the turning point, if you trace along the graph, when the graph change the direction, that's called a turning point. So this is a turning point, this is another turning point, and this is another turning point. See, trace along the graph, right? Go up, hit the top, then go down, hit the bottom, change up. Those points are the turning points. Up, down, up and down, right? So up and down, the point of changing direction is called turning points. Okay, so that's basically the concept of it. And we have some rule for turning points. If a polynomial of degree 5, then it has at most 4 turning points. The number of turning points is less than the degree. Okay, and at most 4. I never say it's exactly 4. At most 4 means what? It may have 4, it may have less than 4 turning points. So for a polynomial of degree 6, it has at most 5 turning points. Okay? And the number of turning points will be going down by 2, by a difference of 2. So polynomial of degree 5 may have 4 turning points, may have 2 turning points, or may have 0 turning points. I didn't see that in the booklet, I was just mentioning it to you. Polynomial of degree 6 may have 5 turning points, and go down by 2 may have 3 turning points, or may have 1 turning point. Polynomial of degree 2 will have exactly 1 turning point, because you cannot go down anymore. Polynomial of degree 1 will have no turning point. It's a line, either going up and going down forever. Okay? Polynomial of 100, a degree 100 may have 99 turning points, 97 turning points, so on and so on. Okay? Excuse me. And that's pretty much about polynomial. And you see what? The turning point in polynomial is no more than what? The local maximum or local minimum. Local max when it turns from what? Going up to going down. It's local max. And then this change from going down to going up, you're going to have a local minimum. Okay? And you may have a bunch of local mins, local max, and a function. Okay. It's supposed to be end right here, but let me just try to extend this a little bit more. Let me try to talk more about something that's I think is going to be useful, even though our textbook did not mention it all. If you have an even degree polynomial, even degree, so see 2, 4, then you may have a graph like this or like this, right? Depends on leading coefficient, positive going up, negative leading coefficient going down, or even degree. Even degree. Yes. What is so special about even degree? Both ending branches or both ending behavior is going to be the same direction, either both up or both down. Okay? With those type of function, guarantee you that you will have a local max, a local mean, right? You will have absolute max, absolute mean actually as well. Because what? If both branches going up, see what? This way, if you go from left to right, it's going down, and eventually at the end it's going up. So it's going to hit the minimum. It's going to attend a minimum somewhere. And same thing here. You go up, and then eventually at the end it go down. You're going to see maximum in the middle. So for even degree polynomial, for sure that you have a max or a mean. Right? What about odd degree? Odd degree. What can we have from the odd degree? Odd degree, the graph could be like this. If the leading coefficient is positive, it tends to go up from left to right. And then going down from left to right is this way. And what domain for a polynomial is always from negative infinity to positive infinity for a math polynomial. Okay? This may change in the application, but in general, from negative to positive infinity. And what is so special about odd degree polynomial? It stands from negative infinity all the way to positive infinity because one branch is down, another one is up forever. So for sure, that graph will intersect the x-axis. Doesn't matter where you draw the x-axis. An odd degree polynomial will eventually intersect with the x-axis. Okay, and like what we learned before, the x-intercept will be will give you a 0, give you a linear factor. So what can you say about odd degree polynomial? For sure, an odd degree polynomial will have a solution. Will have the x-intercept or have a 0. That's how we say it. Okay? And this is a little bit more than what the book tells you, but hopefully you carry it with you, especially when you move on to the next class, pre-calculus. We'll come back and talk about it later. And let me stop our clip right here. Thank you for watching, everyone. Should you have a question, as usual, please don't hesitate to ask. You guys have a great week.